Hello and welcome to our second video on the standard normal curve. This is video 5 of module 6. In this video, we'll investigate solving forward problems, but this time instead of starting with a z-score, we'll be starting with an x. Let's do an example together. Before we begin an example, remember that these are the steps for forward problems. A forward problem is any problem that says find a percent or a proportion or a probability when x or z is a particular value. There are going to be 4 main steps. The first one is to find a z-score and remember to round to the nearest hundredth. Then we'll draw a picture of the standard normal curve, labeling the z-scores and shading in our desired region. Then we'll look up the values on the table by looking outside and then in. And lastly, we'll get an indicated value. If we're looking for the probability, proportion, or percent below, then we'll just take whatever number we get from the table. If it's a between problem, we'll need to subtract 2 values from the table. And if it's greater than, we'll need to subtract whatever value we get from the table from 1. Let's do an example. The diastolic blood pressures for adult women aged 18 to 39 in the United States are approximately normally distributed, with a mean of 68 millimeters of mercury. Assume a standard deviation of 18.1 millimeters of mercury. One of the things that I like to do before delving into a problem like this one is make a summary of the information that's been given to me. This is going to be especially important as we move forward in the last couple of units, because the values that will be given are going to be more and more values and really similar, so we'll need to take care to make sure we define the values properly. In this case, we were told that all adult women in the United States in this age range have a mean of 68 millimeters of mercury. Since this is a population value, we're going to write mu is equal to 68 millimeters of mercury. And I'm writing this at the top of the screen so that I have it for every problem that I'm going to work on. The standard deviation that we've been given will be sigma, and that was 18.1 millimeters of mercury. Once we've done this bit of a summary, now we can start working on a problem. For example, what is the probability that a woman will have a diastolic blood pressure below 75 millimeters of mercury? The first step here is to write down the x value we've been given. So since we're interested in those who have blood pressures below 75 millimeters of mercury, remember x and z are kind of like that cutoff point. So even though we're interested in blood pressures below this amount, we're going to use the amount as the x value. Next, we're going to take this x value and use it to find a z-score. The z-score formula says take x and subtract the mean, and then divide your answer by the standard deviation. So that's where I got 75 minus 68, all divided by 18.1. When I carry out the computation, I end up with a 0.39. Remember that we want to round the z-scores to the nearest hundredth, since that's where the table is set up to be used. However, before I use the table, I need to draw a picture first. So here's my standard normal curve. Since the z-score is a positive number, I'm going to cut it off on the right-hand side here, 0.39. And since we're interested that a woman will have a diastolic blood pressure below this amount, we're going to shade to the left for below. Lastly, I draw this arrow pointing to the left, always to the left, because that's what the table will tell me. For this example, let's review using the table. To use the table, I'm going to need to know this z-score of 0.39. To find the area on the standard normal curve below 0.39, I need to look in the row for 0.3 and the column that has the 9 in it. That's going to be this value all the way to the right. It's in the row for 0.3 and the column for the one that has a 9 in it. That means I'm going to write 0.6517 on the line. This means that 0.6517 of the women in the United States will have a diastolic blood pressure below a z-score of 0.39. For step 4, we need to determine the area of the shaded region. Since the region we shaded is below the cutoff, it matches the value we got on the table. So the value we're interested in is the 0.6517. That's going to be our answer. Let's try a between problem. It's recommended that diastolic blood pressure be between 60 millimeters of mercury and 80 millimeters of mercury. What percent of women have a diastolic blood pressure in this range? Notice that in this problem, we've been given two values for x. We have the 60 millimeters of mercury and we have the 80 millimeters of mercury. Whenever you have two values for x, that means you're going to end up finding two different z-scores. So we have to use the z-score formula twice. The first time we use the z-score formula, I'm going to use the 60 for the x. I'll use 68 for mu, the mean, and 18.1 for sigma, the standard deviation. And when I subtract and divide, I end up getting a negative 0.44. This is also a rounded value. Then I'm going to repeat using this formula, and I'm going to get an 80 minus 68 over 18.1. And when I solve that, I end up with a 0.66. Now that we have the two z-scores, we can advance to step 2, which is draw a picture of the standard normal curve. In this case, I have one negative z-score and one positive z-score. So one of the cutoffs is going to be to the left of 0, and the other one will be to the right. Since we're interested in women that are in this range, we're interested in women that are between these two values. So I'm going to shade in between, and I'll draw my two arrows pointing to the left. Step 3 is to look up the two z-scores on the standard normal table. When I looked up the negative 0.44, I found a value of 0.3300. When I looked up the value of 0.66, I got 0.7454. To complete the problem, we need to find the area of the shaded region. Since this is a between problem, that means we're going to have to subtract the two values we found from the standard normal table. In this case, that means we're going to have to subtract 0.7454 minus 0.3300. When I carry out the subtraction, I ended up getting a 0.4151. Now, if it had asked me what is the probability or what proportion of women have diastolic blood pressure in this range, that would be my answer. However, we were asked specifically what percent of women. That means we need to change this decimal value into a percentage. To do that, you can move the decimal point or simply multiply by 100, and you end up getting 41.54%. Because we want to be as accurate as possible, do not round this to 42%. Leave it as 41.54%. Let's do one more example using the diastolic blood pressures. Women who have a diastolic blood pressure above 90 millimeters of mercury have hypertension, which is high blood pressure. What proportion of women in this age group have hypertension? If you'd like to pause the video here and try this example on your own, that would probably be some good practice. When you're ready, you can unpause the video and resume watching. Okay, let's see how you did. I'm going to walk through my process here. First, I wrote down a little bit of a summary information that we're interested in women who have a blood pressure above 90 millimeters of mercury. So X is the cutoff. X is going to be 90 millimeters of mercury. Then, for the first step, I need to identify the z-score. So I use the formula z equals x minus mu over sigma, or 90 minus 68 all over the 18.1, and I got a z-score of 1.22. This is a rounded value. For the second step, I drew a picture of a standard normal curve. Since 1.22 is a positive number, I drew the cutoff on the right-hand side of 0. Then, since those who have hypertension have high blood pressure, that means I'm interested in values that are above the 1.22, or values to the right of 1.22. That's why I shaded above 1.22. But the arrow always gets drawn to the left, since the table only tells me numbers that are to the left of the cutoff. When I look at step 3, I look up on the table and found an area of 0.8888. For step 4, I need to find the area of the shaded region. Since the 0.8888 is the unshaded region, it's sort of the white or the clear space, I need to subtract that value from 1 to get the shaded region or the red region here. When I carry out the subtraction, I end up with 0.1112. Since they asked us about a proportion of women, I'm not going to change this to a percentage or anything. That's just going to be my answer. How'd we do? This concludes the second video on the standard normal curve. In the next video, we'll examine how to do backwards problems. In other words, instead of starting out with a z-score or an x and coming up with a probability, what if we started with a probability and then had to find a z-score or an x? What might that look like? Thanks for watching, and have a great day.